Hi guys, in this video we're going to learn how to draw graphs when we have more than two sets of data because we've been mainly working with two sets. So remember, the first step is always going to remain the same. So you need to figure out if it's a line or a column graph by figuring out if the data is continuous. Remember, that's things where the data, every single thing, you can estimate between it. So 10 degrees and 20 degrees, 15 degrees exists between that. So that's continuous data, whereas categorical, they're groups, and we often use language like colors to be able to define them. So that should be a column graph. So that's been covered in the first video, so review back the first video on how to draw graphs if you'd like to go over continuous and categorical data. But let's remind ourselves on the splat method when drawing a graph, because even if we have 3 sets of data or 4 sets of data or whatever, we'll still be able to use the splat method. So firstly, we need to have a scale that's even. So every time we go across a box, if we say it's worth 2, it has to be worth 2 every time. Or if it says 3, 3 every time. We can plot our data. So remember, if it's a line graph, we're going to use a very small x and it has to be accurately plotted, which means in the correct spot. Or if it's column graph, we have to have ruled columns with lines and consistent gaps between them. So if you leave a 1 box gap at the beginning, there's a 1 box gap between every bar. Don't forget to label your x and y axes with units. And it's always important that the y-axis must be the dependent variable. And that's something that's really going to help us in this more than 2 sets of data. So the y-axis is always the dependent variable. Don't forget that you only ever graph averages, okay, not the trials, not unless it specifically asks you to. And then have a title that is clear and informative, and it should include the independent and dependent variable. So we should always try and when we have a look at our data, identify those as well. So let's have a look at some information. So we've got graph the following data. We've got weeks here. We've got the growth height of a plant, and then we've got a plant receiving 1 mil of fertilizer, one receiving 3 mils, and one receiving 5 mils. So let's think about, well, before I can even start labeling my axes or anything like that, I need to figure out what are my independent and dependent variables. So let's remind ourselves back to the cows moo softly, I don't care. So the thing that I'm purposely changing is my independent variable. So we can see here that if we look at our plants, you know, the weeks are going by. That's not what we're purposely changing between them because the week's happening for all of them. We're looking at the growth height. We're measuring that. We're not purposely changing that ourselves. So the thing we're purposely changing here is the amount of fertilizer received. So we're going to write as our independent variable is the amount of fertilizer received daily. Okay? So that means that what we measure is our dependent variable. Now, we might measure a few things, but what we're measuring on purpose as our results is our dependent variable. So we might be measuring as the weeks go by, but that's the same for every single one of them. So that's not our dependent. That's not what we're measuring as our results. We can have a look here. What we're measuring across each of the 3 plants is their growth height in centimeters. So now we know that the dependent variable is the growth height in centimeters. Okay, and then lastly, like we can think about, it's not relevant to the graph, but we can think about, well, what were the things that needed to be kept the same to make this controlled? We probably needed to start with the same type of plant. We had to have the same starting height, so we can see that as well. So let's have a look at starting to actually draw this graph. Now we know that our variables are. So let's not forget, we said that the y-axis is always the dependent variable. So this is our y-axis, okay? This is our x-axis. So we know that this needs to be growth height in centimeters. All right. Now, usually we would go, okay, well, whatever's left over is on our x-axis, and that was our independent variable. But when we have 3 sets of data, not only do we need to have something indicating the mils that the plants are receiving, but we also need weeks now. So in a graph that has more than 2 sets of data, the independent variable always goes in something called a key. Okay, and the reason why this happens is because we're going to actually be plotting across weeks, which is down here, the growth height of the plants and the different fertilizers. So that's an important thing. I'll say that one more time. When we have more than 2 sets of data, as always, the dependent variable goes on the y. But now the independent variable isn't on the x because we've got a 3rd set of data, so our independent variable goes into a key. Alrighty, So now that we've done that, we've labelled our axes with our relevant units. Let's go to a scale. So for weeks, we've got to start at 0, and let's see if we can fit 10 across here. So if we go across 1, 2, 3, 4, 5 boxes, 2, 1, 2, 3, 4, 5 boxes, 4, 1, 2, 3, 4, 5 boxes, 6, 1, 2, 3, 4, 5 boxes, 8, 1, 2, 3, 4, 5 boxes, 10. Okay, so you can see that I've used a consistent scale there. Now we need to have growth height on this side. We need to get all the way up to 42. So remember, the way that we can do that to figure out how we can get all the way up to 42 is we can count how many boxes I have here. So 5, 10, 15, 20, 25 boxes. And I know that 42 has to fit across those 25 boxes. So I go 42 divided by 25. And it tells me that each box has to be worth about 1.68, or we could make it worth 2. So I can go 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And 2, 4, 6, 8, 10. And 2, 4, 6, 8. Okay, so then that's going to be 10. All right, so now that I've done that, I've got my 2 scales done. I'm now going to plot it. Now, something I should have talked about later, we know that this has to be a line graph because we've got continuous data. Weeks is continuous, and we also know growth height is continuous. They're not categories. So let's start to plot this for 1 mil. So we know at 2 weeks, it was 4, so I'm going to go up to 4. At 4 weeks, it was 8. I'm going to go up 2, 4, 6, 8. At 6 weeks, it was 12, so 2, 4, 6, 8, 10, 12. At 8 weeks, it was 16, so 10, 12, 14, 16. Then at 10 weeks, it was 20. Now remember, you get your ruler out here, and we always make sure that we connect these with a straight line. Okay, dot to dot. All right, now I'm actually going to decide to use a different color for today to do the 3 mils, just so it's really easy to see as I'm drawing this for you. Okay, so we'll use 3 mils as red. It's still going to be a square. So then at 0, it's going to be down here as a little square. It's okay to overlap that. Then it's going to be at 2, it's going to be 7. And at 4, it's going to be 13. Okay, at 6, it's going to be 19. At 8, it's going to be 25. 10 is going to be 31. And then once again, I'm going to make sure I use my ruler to draw a straight line between each of these data points. Okay, and then lastly, I'm going to use a different color again just to make it really easy for you. Okay, you're allowed to do that in exams as well, guys. For 5 mils, once again, it started at 0. And then it was 10 at 2 weeks. 4 weeks, it was 18. 6 weeks, it was 26. 8 weeks, it was 34. 10 weeks, it was 42. Okay, and then once again, get my ruler out and draw a straight line. All right, and so we've only got left one last thing, which is we need to write our title because we have done our scale, we've plotted our data, we've made sure we did the averages. Now we're going to do our title. So we're going to say the effect of different fertilizer amounts on plant growth. Okay, so if we want to review all the way from the beginning, we're going to say, even when we have more than 2 sets of data, we're often going to work with 3. First, start by, is it continuous or categorical to figure out if it's a line or column graph. Then you're going to use the splat method as normal. So you have to have a consistent scale. You're going to plot your data, have your labels, always the dependent variable on the y-axis every single time. When it's 2 sets, you're going to then have your x-axis as the independent. But when we've got 3 sets of data, we always know that the independent variable is going to be in a key instead. We graph averages and have a title. Now, our key looks like this. We box it in. We can use different colors. We can use different shapes. And then we connect our lines with dots to dots. Okay? All right, well done, guys. And that was how to draw graphs with more than 2 sets of data.